Bismillahirrahmanirrahim. This is our lecture number 5. It is related with exercise. We have exercise regarding the lemmas we have learned in lecture number 4. We have learned one lemma related to the unique solution. If it says that if the rank of coefficient matrix equals to the rank of augmented matrix equals to number of unknowns, then any system of linear equation has a unique solution. Second lemma tells us about inconsistent system. If any system satisfying this condition, that is rank of coefficient matrix is less than rank of augmented matrix, not equal to number of unknowns, so then we may say the system has no solution, or the system is inconsistent. Third lemma tells us about the infinite number of solutions. So if number of unknowns is not equal to the rank of coefficient matrix equals to rank of augmented matrix, or in other words, you know that the rank of coefficient matrix equals to rank of augmented matrix, and both are not equivalent to number of unknowns. So you may say that the system has infinite number of solution. These all we have done, and also in last lecture we learned about the Gaussian elimination method and Gauss-Jordan method. Today we'll do few exercise problem related with lecture number 4. Problem number 1. Use Gaussian elimination method to solve the following problems. That is, equation number 1 is x1 plus 2x2 plus x3 equals to 1. Second equation is 3x1 plus 5x2 plus x3 equals to 3. Third equation is 2x1 plus 6x2 plus 7x3 equals to 1. First we write that system of equation into matrix form. So that matrix is known as augmented matrix. So you see here, first matrix we have, that is the first matrix. That is the first matrix 1 2 1 1 3 5 1 3 2 6 7 1. So that is of augmented matrix. You may say that matrix is, and why we are applying here elementary operation, because we want to find its reduced echelon form, that is the reduced echelon form. So in order to convert from augmented matrix to reduced echelon form, we have to apply here different operations. First, here we have the leading one, you see, and below leading one we want to convert all elements equivalent to 0. So first we multiply row number 1. First we multiply row number 1 by minus 3. So if you multiply row number 1 by minus 3, minus 3 1 is minus 3, minus 3 2 is minus 6, minus 3 1 is minus 3, minus 3 1 is minus 3, and if we add after multiplication, we have to add that row in second row. So 3 minus 3 equal to 0, 5 minus 6 is minus 1, 1 minus 3 is minus 2, 3 minus 5, 3 minus 3 is equal to 0. So similarly, In order to convert that 2 becomes 0, we have to apply here second row operation, that is A13 minus 2. What does it mean? We have to multiply row number 1 by minus 2. So if you multiply row number 1 to minus 2, it means minus 1 minus 2 minus 4. Here we have minus 2. Here we have minus 2. So if we add that row into second row, so it means minus 2 plus 2 equal to 0, minus 4 plus 6 2, minus 2 plus 7 5, minus 2 plus 1 minus 1, right? Similarly, we want to find a key element on second row. In order to find a key element on second row, we have only three options: whether we multiply it by any element, whether we add it applying addition operation, or whether we apply here permutation. So I think multiplication is best here. So if you multiply second row by minus 1, so we'll have 0 1 2 0. The second row becomes 0. So why we are doing so? We want to find a key element in second row, second column position. So by using that leading one, we want to convert below all other elements equal to 0. So in order to convert all elements equal to 0, we have to apply here addition operation. First we multiply row number 2 by minus 2. So if you multiply row number 2 by minus 2, so it means minus 2 zeros are 0, minus 2 ones are minus 2, minus 2 minus 2 is a minus 4, minus 2 zeros are 0. So if you add it to row number 3, so 0 minus 3 0 0, minus 2 plus 2 0, minus 4 plus 5 1, 0 minus 1 1. So now we have that matrix called ref. That matrix is ref, reduce echelon you know about ref, and first week lecture we have already done few exercises related with ref, right? The last matrix, if you convert the last matrix into system of equation, so here we have the system of equation x1. Here system of equation is, it is system of equation x1 plus 2x2 plus x3 equal to 1, x2 plus 2x3 equal to 0, x3 equal to minus 1, right? So by backward substitution, what does it mean backward substitution? We just substitute x3 minus 1 into back equation, second equation. So if you multiply 2 by minus 1, so we will find the value of x2. Similarly, if you substitute the values of x2 and x3 into equation number 1, we will obtain the value of x1. So as a result, we will have the values of x1, x2 and x3. The value of x1 is minus 2, the value of x2 is 2, the value of x3 is minus 1, and we may prove these values by using the lemma. So here we may apply that lemma. The rank of coefficient matrix is 3. You see, rank of coefficient matrix is 3, and rank of that whole augmented matrix is also 3, and number of unknowns is also equal to 3. So that lemma tells us that the system has a unique solution. So you see that is the unique solution, minus 2 2 minus 1. So that is your assignment. You may solve at home. These are two problems. The first is 3x1. You have to find the values of x1, x2, x3 by using Gaussian elimination method, right? So in example 3, first you have to write it as augmented matrix, and then you have to apply several elementary row operations, and then you have to find ref, reduce echelon form. After finding ref, you have to write it into system of equation and then substitute backward equation in order to get the solution set. Similarly, in example 2, First you have to write the three equations into augmented matrix, and then you have to apply here the elementary row operations, and after applying elementary row operations you have to find out ref reduce echelon form. Then by using reduce echelon form you have to find the solution. First to convert it into system of linear equations, and then substitute backward to find out the values for x1, x2, x3, and try to apply these lemma we have learned in lecture number 4. Apply that lemma to prove these solutions. Next example: determine all values of the constant k for which the following system has no solution, has infinite number of solution, has a unique solution. So you may find the values of k by using the lemma we have learned in lecture number 4. So first we have to find the ref of that matrix. So first we have to write that matrix 2x1, that equation, system of equation 2x1 plus x2 minus x3 plus x4 equal to 0, x1 plus x2 plus x3 minus x4 equal to 0, 4x1 plus 2x2 minus x3 plus x4 equal to 0, 3x1 minus x2 plus x3 plus kx4 equal to 0. So first we write it into augmented matrix. You see, that is the augmented matrix for that system of equation: 2 1 minus 1 1 1 1 1 1 minus 1 4 2 minus 1 1 3 minus 1 1 k. Right? So what is the required things in that question? Here you see in the question, determine all values of the constant k. So where is k? K is in the last row. Right? So first we convert that matrix into ref by using elementary row operations. These are the elementary row operations. First we write it into elementary row operation. Here we in order to get ref, we permute row number 1 to row number 2. So that is permutation operation p12. So we'll obtain 1 1 1 minus 1 0. So now we have that 1 as a key element, and then by using that row we may convert that 2 equal to 0. So here we have to apply that addition operation. We multiply row number 1 by minus 2 and add it to row number 2. So we'll obtain 0 1 3 minus 3 is 0. And in order to convert that 4 equal to 0, we must multiply row number 1 by minus 4 and add it to row number 3. So we'll obtain 0 minus 2 minus 5 5. And again we want to convert that 3 equal to 0. We must multiply row number 1 by minus 3 and add it to row number 3. So we'll obtain, you see, leading one, and below leading one we obtained here all zeros here. Next, here we have to find the key element. We must multiply it in the second row by minus 1. You see, multiply row number 2 by minus 1. So we'll obtain 0 plus 1 plus 3 minus 3. And then using that key element 1, we must convert below 1 equal to 0. Right? So here we have to apply that two elementary row operations. Here you see, here we have to apply two elementary row operation. In order to convert it equal to 0, we multiply row number 2 by plus 2 and add it to row number 3. You see, row number 2 by multiply 2 and add it to 3. So we will obtain 0 here. Similarly, in order to get 0 in position minus 4, we multiply row number 2 by 4 and add it to row number 4. We'll obtain 0 0 10 k minus 9. Again, that key element we have already found, and by using that key element we want to convert below key element equal to 0. Alright, so in order to convert it equal to 0, we have to apply here that row operation A34 multiplied by minus 10. So we multiply row number 3 by minus 10 because here is positive 10. So here we have to multiply row number 3 by minus 10. So we will obtain 0, 0, minus 10 plus 10 and add it to row number 3 to obtain 0, 0, 0, k plus 1, 0 here. Right? So what is the required thing? First question, no solution. So what does it mean, no solution? Lemma tells us that if the rank of coefficient matrix is less than the rank of augmented matrix, the system is inconsistent. So it means if you put all the values of k from minus infinity to plus infinity, v does not satisfy that condition of inconsistency for this system of equation. So it means there are no values of k for which there is no solution. For all values of k there exists a solution here, and the trivial solution is 0, 0, 0, 0 here, right? So that means we cannot find no solution in the last matrix. There always exists one of the solution here. Second, an infinite number of solution. So the lemma tells us how the condition for infinite number of solution is that the coefficient, the rank of the coefficient matrix is equals to the rank of augmented matrix. So here you see the rank of coefficient matrix is 4 and the rank of augmented matrix is also 4. Yes, you see rank of coefficient matrix is 4 and the rank of complete matrix is also 4. You see, so both ranks are equivalent to both rank 4. But what is the condition for infinite? It must be less than number of unknowns. Okay, so in order to convert less than 0 to, we must less than 4. So what is the value for less than 4? It may be 3. Yes, the rank. So it means the rank of coefficient matrix must be less than 4. So in order to convert less than 4, we must put in place of k equals to minus 1. Yes, here we put here minus 1. So it means if we put minus 1, that whole row becomes 0. So what is the rank now? Rank is 3 and number of unknowns is 4. So it tells us that the system has a infinite number of solutions. A unique solution. Number C condition tells us, so how we find a unique solution? So by lemma, if you say lemma it tells us that the rank of coefficient matrix equals to rank of augmented matrix equals to a number of unknowns, right? So rank of coefficient matrix is 4 if you plug in the value of k not equal to minus 1, and rank of augmented matrix is also equal to 4 and both are maybe equivalent to number of unknowns. So we may put here all the values of k except minus 1, right? If you plug in all the values of k, so it satisfies the unique value condition for final matrix. So what it means? A, no solution, there does not exist any value of k, find no solution. In part B, an infinite, so here the answer is the k value equal to minus 1. And part C, what should be the value of k for a unique solution? So we must put all the values of k except k equal to minus 1 in order to find a unique solution. Right? Next example. Determine all the values of the constant k for which the following system has no solution, infinite number of solution and a unique solution, right? So again we have to apply these three lemmas here: lemma for no solution, lemma for an infinite number of solution, and lemma for a unique solution. So in order to find the values of k, we must write that system of linear equation into augmented matrix. That is our augmented matrix: 1, 2, minus 1, 3, 2, 5, plus 1, 7, 1, 1, minus k square minus k. So that is our augmented matrix. here we have to apply addition operation. First we multiply row number 1 by minus 2 and add it to row number 2. If you multiply row number 1 by minus 2, it means we will have minus 2 so if you multiply row number, in order to find out zeros here, we have to apply addition operation. In addition of what does mean addition operation? First we multiply row number 1 by minus 2, so here we have minus 2. Again row number 1 by minus 2 means minus 4. Minus plus 2 and minus 6. And then add it to row number 2, so minus 2 plus 2, minus 2, that is plus 2. Answer is 0. Minus 4 plus 5 is 1. 2 plus 1, 3. Minus 6 plus 7 is 1 only. Similarly, we want to find out the zeros on the second row, third row position. So you must apply here addition operation. First we multiply row number 1 by minus 1. If you multiply row number 1 by minus 1, so we will obtain minus 1. Here we will find minus 1, right? Minus 1. Again, if you multiply row number 1 by minus 1, minus 2 plus 1, minus 3. So if we add that row to row number 3, so minus 1 plus 1, it is equivalent to 0. Minus 2 plus 1, it is equal to minus 1. And then 1 minus k square is that element, and minus 3 minus k. So that now we have it satisfies the first condition of ref, that we have the leading one on the first row and below leading one all element equal to 0. On second row we have the leading one, that is 1, and below leading one we must convert minus 1 equal to 0. So how may we achieve that target? We must multiply row number 1 by plus 1 and add it to that row. So if we apply addition to 1 minus 1 equal to 0. 3 plus 1 means 4 minus k square, and 1 minus 3 means minus 2 minus k, right? In that way we may obtain, finally we obtain that augmented matrix 1 0 0 2 1 0 minus 1 3 4 minus k square 3 1 minus 2 minus k, right? So listen the azan, please wait for a few minutes. Okay, now listen, in part A we have to find no solution. So the lemma tells us if the system has no solution satisfy that condition, the rank of the coefficient matrix must be less than the rank of the augmented matrix, right? So if the rank of coefficient matrix become 2 and the rank of augmented matrix become 3, so we may say the system has no solution, right? So if you plug in the value in play k equal to 2 and k equal to 2, will obtain here. You see, if we put the value of k equal to 2, it means we will have 0, 0, and k equal to 2 means it also becomes 0, and it means if you put here k equals to 2, so it means minus 2 minus it becomes minus 4. Now you see the rank of coefficient matrix is 2 and rank of augmented matrix is 3, so 2 is less than 3, yes, so it means system has no solution. If you plug in the value of k equals to 2, then the last row of last augmented matrix reveal an inconsistency and the system has no solution in this case. Okay, similarly for part B, just I rub it. For part B, in part B, what it asking about an infinite number of solution. So what is the lemma tells us? And for infinite number of solution, rank of coefficient matrix equals to rank of augmented matrix, and both must be less than number of unknowns. So number of unknowns here, you see, number of unknowns here in this matrix, number of unknowns is n equals to 3. So number of unknowns is 3, right? And number of coefficient, if number of coefficient matrix, rank of coefficient matrix must be equal to 2, and rank of augmented must be equal to 2. So what value should be put here in order to get the rank of augmented matrix equal to 2? So if you plug in here all the values except if you plug in here value of k equal to minus 2. So you plug in k equal to minus 2, it means we'll have in last row becomes, if you plug in k equal to minus 2, k equals to minus 2, so that row becomes 0, that it becomes 0, and if you plug in k equals to minus 2, it means 4 minus 4 is 0. If you plug in here k equals to minus 2, minus 2 plus 2 also equal to 0. So now rank of matrix is equivalent to 2 and rank of augmented matrix is also equivalent to 2, and both are less than equal to 3, so it will give you the infinite number of solutions, right? So third, part C, we want to find a unique solution. So how we obtain the unique solution here? So unique solution, we find the unique solution by plugging different values of k in last matrix. If you plug in k, all values of k here except k equals to plus minus 2, so we'll obtain here a unique solution condition. So in unique solution condition, in that lemma it tells us that if the rank of coefficient matrix equals to rank of coefficient matrix equals rank of coefficient matrix equal to rank of augmented matrix equal to number of unknowns. So we plug in all the values of k except minus 2 and plus 2, you will obtain here a unique solution. We may check here. First I erase these values. Okay. So in order to find a unique solution, if you plug in k equals, let's suppose all the values of k except plus minus 2. So let's suppose 3. If you plug in 3, so here in place of k the 0, it is equivalent to 0. 4 minus 9. 4 minus 9 is minus 5. Here again, if you plug in place of k equals to 3, so minus 2 minus 3 minus 5. So you see the rank of coefficient matrix is also 3, rank of augmented matrix is also 3, and both are equals to number of unknowns. So it tells us that system has a unique solution because it satisfies that condition of unique solution. What is that condition? If the rank of coefficient matrix here in this question, the rank of coefficient matrix is 3 and rank of augmented matrix is also equal to 3 and both are equal to number of unknowns, so it means the system has a unique solution. So it means if you plug in the value of k in reduced echelon form for no solution, so if you plug in k equal to 2, so we'll find no solution. If you plug in k equal to minus 2, we'll obtain infinite number of solutions. And if you plug in the value of k not equal to plus minus 2, so then we'll obtain the system has a unique solution. Next example, determine all the values of the constants a and b for which the following system has no solution, an infinite number of solutions, and a unique solution. So first we have to write the given system of linear equation into augmented form. So that is the augmented form. We have 1 1 minus 2 4, 3 5 minus 4 16, 2 3 minus a b. So that form is known as what? That form is known as the augmented matrix form, augmented matrix for this system. So you must convert that matrix into this one, that is the ref. So how may we obtain ref? So here we have to apply, first we apply addition operation. So by using row number 1, we have to convert the second element equal to 0. So if you multiply row number 1 by opposite sign of 3 is minus 3, minus 3, 1 minus 3 is a minus 3, minus 3 into minus 2 is plus 6, minus 3 into 4 minus 12, so if you add that row into second row, so it means minus 3 plus 3 is 0, minus 3 plus 5 2, 6 minus 4 is 2, minus 12 plus 16 is also equal to 4. So now we'll have that matrix. So similarly we may apply here different row operations, and finally in order to save time we'll obtain that matrix. That matrix is in form of ref, which since what does it mean ref? Ref we have already done in first week lecture. It is called reduced echelon form, right? So in the first question it asking about no solution. So that what is the condition for lemma? What it means, if you plug in here a equal to 3, so the rank of coefficient matrix is equals to 2, and if you plug in b is not equal to 10, so it means the rank of augmented matrix is not equal to 3. So it means if you plug in these value into that equation, in the last equation, plug in a equals to 3, so it will give you the rank of coefficient matrix is equal to 2, and if you plug in the value of b is not equal to 10, any other value, so we obtain the rank of the augmented matrix. So it means the rank of coefficient matrix 2, rank of augmented matrix 3, and both are not equal to number of unknowns. So it's satisfying that condition of lemma for no solution if you plug in the value of a equal to 3 and plug in the value of b equal to 10. Second part, the question in second part, it is asking about an infinite number of solutions. The lemma tells us that if the augmented matrix rank equals to the rank of coefficient matrix and both are less than number of unknowns, so you must convert that element 3 minus a equals to 0, and b minus t you must convert also equal to 0. So what are the values for a and b? So if you plug in place of a equal to 3 and in place of b equal to 10, so you see these two elements become equal to 0, right? So you plug in these two values, a equal to 3 and b equal to 10, that means that element become equal to 0 here. So the rank of coefficient matrix now equal to 2 and the rank of augmented matrix is also equal to 2. Rank of coefficient is 2 and rank of augmented matrix is also equal to 2, and both values are less than number of unknowns. And what are the number of unknowns? Number of unknowns is 3. So it means satisfying the lemma condition for a equal to 3 and b equal to 10. In condition question number 3, we have to find a unique solution. So if you plug in here in place of a all the values of a and all the values of b except 3 or 10, we may obtain a unique solution. It is for exercise. Determine all. It is assignment, you may say. Determine all the values of the constant k, constant a and b for which the following system has no solution, an infinite number of solutions, and a unique solution. So try the question. Since these questions are important from midterm point of view. Okay. In next lecture number 6, we will do application regarding system of linear equations. Thank you.